Welcome. In this video, we are going to go over some probabilities which occur when rolling an 8-sided die. So to the right is a sketch of an 8-sided die. And if you haven't seen these before, these are used in like role-playing games, and a lot of board games now use them as well. Clearly we can't see all the sides, but there are 8 sides numbered 1, 2, 3, 4, 5, 6, 7, 8. And I just answered our first part of our question, by the way. So let's let event A, the result is odd, and event B, the result is even. So before we go into any probabilities, let's describe the sample space. So our sample space S includes all the numbers on the die, 1, 2, 3, 4, 5, 6, and we keep going in like a standard cube die to 7 and 8. Now let's find the complement of A, and then compute the probability of A and the probability of the complement. So the complement of A can be denoted two ways. You can denote it with an apostrophe as I've done here, or you can denote it with a bar on top, and I'm going to include both just so you remember that both of these are the complement. And so A is the result is odd. That means that A here is equal to 1, 3, 5, 7. So a complement are all the outcomes that are not in A from our sample space. That's 2, 4, 6, 8. So now let's compute the probability of A. Well, the probability of A, which we see here, is A. There are 1, 2, 3, 4 possible ways to get an odd number when rolling this 8-sided die. So the probability of A is 4 out of 8, which is 1/2. And as a decimal, we can write 0.5. Now, A complement, well, if you notice event B is the result is even, these are all even numbers. So in fact, the complement of A is equal to event B. So the probability of this, of A complement, is equal to the probability of B. There are 4 ways to get an even number out of 8, and that's a half again. So one interesting thing to make note of here is that if I add the probability of this event A and the probability of its complement, I get 1. That is the probability of A plus the probability of A complement equals 0.5 plus 0.5 equals 1. And that's always the case in an event. Its probability added with the probability of its complement will equal 1. Okay, let's move on. Let's see this event be the result is an odd face larger than 4. And D is the result, an even face smaller than 5. What is the probability of event C and event D occurring when rolling this 8-sided die? So C is equal to an odd face larger than 4. So that's 5 and 7. And event D is an even face smaller than 5. So 5 would be here. So even faces smaller than 5 are 2 and 4. Now let's look at the probability of C. The probability of C is equal to 2 out of 8, which is 1/4. And you can write that as 0.25. Probability of D is also going to be 2 out of 8, which is 1/4, and that's 1/4. So I've just gotten the probabilities of the events separately, but what about them occurring? So C and D. So that's probability of A and, oh, what did I write A? Excuse me, I meant to write C. So we can write C and D. And a way to equivalently denote this is probability of A and, I keep wanting to call this A, excuse me, probability of C and D. There we are. Well, what's the probability that we roll both an odd face larger than 4 and an even face smaller than 5? Well, it's 0. These events cannot occur at the same time, so they're mutually exclusive. There we are. Events C and D are mutually exclusive. Now let's look at part D. Let E be the result, or the event E be, the number is less than 7. Are events C and E mutually exclusive? So let's write out all the possible outcomes for event E. So we need a number less than 7. What numbers are less than 7? Well, 1, 2, 3, 4, 5, and 6 are all less than 7. 8 is greater than 7, and 7 is equal to 7, so it's not less than 7. So we just have the numbers 1 through 6. So now let's answer the question, are events C and E mutually exclusive? Well, if you notice, event E includes 5 and event C includes 5. So in fact, the intersection of event C and event E, that is C and E, is equal to 5. So they are not mutually exclusive. I hope you found this video helpful.